Coming to the feedback amplifiers. You should know if the circuit is given to you, we have to know how to identify the topology. For that, we'll go with the block diagram of the feedback amplifier once. This is the amplifier, and this is my beta network. For suppose we have to concentrate from the amplifier to the beta network what kind of sampling method it is followed and what kind of mixing process it is following. So based on that, the type of the sampling and the type of the mixing it is done over there in the feedback network, we can define the topology. So for separately sampling type and mixing type, how we identify is once like my transistor is given like this. This is my transistor, and I will be having four possible ways of like identifying the sampling type. So let me draw the transistor circuit for four times. This is another transistor. This is another transistor, and this is another transistor. Yes, and the possibilities over here for the multiple transistors might be taking the output from this one and taking the output from this one and taking the output from this one and taking the output from this one. In the first two cases, we are taking the output across the across the collector terminal, and in the third and fourth case, where we are taking the output across the emitter terminal. A feedback signal can be taken from the same electrical node. This is the electrical node across which we will take the output. From the same electrical node, I will be taking my sample. Yes, and in the second case, I will be taking my sample from the opposite node. If it is so, if it is so, I can define my sampling type is from the same voltage node. If I take a sample, that is called voltage sampling. And over here it is from the opposite node, so I call it as a current sampling. So this is just like a general observation point of view I'm trying to say, where like most of the questions and most of the competitive exam problems can be solved like so. And from this is what the electrical node across which will take output. In that case, there is a possibility if I take my output from this opposite node or from the same node. So from this, that opposite node is considered in the sense this is what voltage node. I take a sample from the current node, so I call it as a current sampling. This is what my current sampling. So this is the voltage node from where like I take a sample, so I call it as a voltage sampling. So now these are the four possibilities that I have, either the voltage sampling and current sampling, that based on where you take output. So this is how like we define the type of the sampling. In the similar fashion, if you go with the mixing type, if it is a transistor circuit at the input side, if we see this is what my base terminal, this is what my emitter terminal. So now actual input of the transistor is this is plus and this is minus. Now whatever the sample we got it, this is how we got a sample. So this sample will be getting it over here, that we can mix it over here, or else you can mix it over here at the emitter branch or at a base branch. If it is mixed at emitter branch, your input signal of this one is getting subtracted by the feedback signal. So your feedback subtracts your input signal, or if subtract the current signal. Based on that, I can define my mixing type. If it is subtracts your input, that is called series mixing. Subtracts current, that is called shunt mixing. So simply I can say one thing, your feedback signal, is it mixed at emitter or is it mixed at the base? If it is mixed at the emitter, that is called a series mixing. If it is mixed at the base, it is called a shunt mixing. So from the topology, that kind of circuit is given where my feedback signal is started and where it is going to be ended across the two transistors, either like output transistor or input transistor. Based on that, I can define my sampling type and I can define the mixing type. So both together I can easily define the topology of my feedback amplifier. So let us see the different examples over here. So this is like we have different examples over here. If you see, this is what a transistor T2. If you see, this is what my output, this is what electrical node. Across the electrical node of V, I will be taking my sample. So I call this one is a voltage sampling. This is my voltage sampling. Yes. So after like I take a voltage sampling, I'm trying to mix it over here. This is what my emitter terminal. So once I mix it at emitter terminal, this is how like I have a V input across the first transistor. My voltage signal is getting subtracted. Voltage signal is getting subtracted, or else like if it is mixed at emitter, I call it as a series mixing. Series mixing. So now I can put the topology type is voltage series a feedback amplifier. This is how I define the type of the amplifier topology based on the sampling type and the mixing type which I know. In the similar fashion, here also this is the electrical node where across which I will take output, and the sample is also going. This is how I take a sample from this one. So sample is going over here and mixing it over here. Sampling is going over here and it will be mixed over here. Yes, so from the same electrical node where we take the output, it is taken the sample. So I call it as a voltage sample. So the sample type is voltage sampling. So I have a voltage sampling it over here. I have voltage sampling over here. Now if you see, this is what my base branch and this is what my emitter branch, where like this is what input. I mixed my sample, collected my sample and mixed it over here at the base branch. So it is called a shunt mixing. So both together we can put it as a topology, right? Voltage shunt feedback amplifier. And in the similar way, if I see that remaining circuits also, where this is what electrical node we have the notation V, so this is the opposite node, we have the notation opposite notation I. So my sample is collected from the opposite node, so I call it as current sampling. Current sample, it is mixed at the base branch. Base, this is emitter. So now my current is getting subtracted, where like this is what IS current, this is what my IF current. So now this will be IS minus IF, that will be your I input. So current signal is getting subtracted, or else like that feedback signal is mixed at base branch. So anyway like we can remember. So this is what for shunt mixing. So if you combine together current shunt feedback amplifier. So in a similar way, last one, where we take the output from this one. So from the same node, we will take a sample. So this is what your voltage sampling. This is, we call it as voltage sampling. And here this is actual current IS, right? IS or I input, that is the notation. So here the feedback current will be IF, let us suppose. It is subtracted over here and remaining current will be going. Yes. So now this current is over here is minus of I input minus I F. So means that current is getting subtracted. So current is getting subtracted in the sense this is what your shunt mixing. So voltage shunt, shunt feedback amplifier. So this is how four topologies were easily identified based on the type of sampling and type of the mixing which we are using at output and input sections. In the similar way, that two more problems that we have. So here the question is like in the same way it is asked, but the circuit diagram is not looking easy. Where let me redraw the circuit diagram. So this is what your VCC, where it is connected with this is what your RC network, this is what your RB network, let us suppose RB. So that RC is connected to collector of the transistor, this is a collector of the transistor, and it is connected to the ground, and base is connected with the V input, Vi, and there is a feedback from the output to the input. So where across like output is this is what your output. Yes, this is what your output, and means this is what my output. I consider this is what my voltage node from the same voltage node. So this is what my voltage node. This is the same voltage node from which I will be taking my sample. So this is how I take a sample, and this is called RB. That is what your feedback network. It is mixed at the base branch. Yes, so the sample is collected over here and mixed over here. This is called my beta network, a feedback network. So from this, what I do is my sample is collected from the voltage network, a voltage node. I call it is voltage sampling. I call it as voltage sampling. And it is mixed at a base branch. It is called a shunt mixing. So both together we call it as voltage shunt feedback amplifier. And final one is, so this is your common emitter amplifier, where you give the input at the base terminal, take the output at the collector terminal. So now we don't have a feedback network over here. Previously this is what my feedback network, and in this section this is how dedicatedly feedback network, this is how the dedicatedly feedback branch is there, and this is how dedicatedly feedback branch is there, and here also there is a dedicatedly feedback branch was there, and here also dedicatedly feedback branch is there. So now this is a difficult analysis where across the common emitter we have to treat that particular branch where which is common to the input and output. This is what my input, and this is what my output, where I see this is what your branch, this is what our branch which is common for the both input and output. I consider this is what my feedback. So this is called my feedback network. And what I do is I will be observing that this is the electrical node from which I will be collecting my sample to the beta network. This is called my beta network. Let us suppose what happening, my beta network is taking the sample from which node? From the same node. If the transistor is, if it is like this, if my transistor is like this, if this transistor is like this, what I have, so this is what the electrical node, this is what my beta network, that is what your RE, it is taking the sample from this one. So from this one, if the same circuit, if you see my beta network, this is what my beta network, feedback network, which takes the sample from emitter node. So this is what my emitter node. where I observe that this is what my output, so I call it as a voltage node. So opposite of that one is considered as a current node. So it will be taking a sample from the current node. I call it as a current sampling. After it will collect the sample, what it do is, so it will be mixing the sample. So it will be taking the sample and it will be taking the sample and it will be mixing over there across the same node. It will be mixing across the same node. It will be mixing across the same node. As we know, if the sample is mixed at a base branch or emitter branch, there are two cases. Based on that, we define the type of the mixing. So as we see, that sampling is mixed over here by the beta network at the emitter branch. So this is how like a V input. If that mixing at a emitter, that is your series mixing. So combinedly, if you see, this is what your current series feedback amplifier. In another case, if it is not a common emitter amplifier, if let us suppose this is not a common emitter amplifier, you take output from this one. So then you are taking that sample from the beta network. We are taking the sample from the voltage node, same node. So it will be becoming like a voltage sample. So I can say common emitter amplifier is this one, is nothing but a current series feedback amplifier. If it is a common collector amplifier, it is a voltage series feedback amplifier. So this is how we define a topology for any kind of feedback amplifier based on identifying sampling type and mixing type.